I'm very pleased to announce a speaker I've been hoping we'd have for years. He's been doing great astronomy from Rowan State. And Ted Stryk, Dr. Ted Stryk, is an associate professor in English and philosophy. But he's been a lifelong lover of astronomy. He started out in Bristol. He's gone to school at Carson Newman and UT. And
Northern Arizona University.
Oh yeah.
Northern Arizona.
Northern Arizona University, where the skies are nice. So, like me, I guess, like a lot of you, like Noah, he's done some film photography. And so what do you do when you want to do good astrophotography? You got your telescope. How can you make it better? Well, more aperture, but things get fuzzy. Fancy image processing, stacking, so forth. But what if you say, I want to put my telescope closer? And that's something we don't really ask ourselves. It doesn't usually make much sense. You're not going to turn it into a microscope, but you can take it on an airplane or to a mountaintop. Well, Ted does it better. He puts it on a NASA probe. So he's using NASA images from space probes and doing really interesting things with it. You can correct me if I got it wrong.
I like the way you described it. I never thought of it that way.
That's the way I think of it. It's cool. It's cool because we do everything here, making our scopes work better, but why not just take the scope and move it to the object? So he's been doing that, and not only has he been getting neat results for a long time, looking at planetary images, but NASA has finally recognized that. He's part of the New Horizons team. He's been traveling around with them some and looking at the fresh data from Pluto, and you send out Valentine cards with the Pluto heart on them.
I should have done that, but I didn't send out Valentine cards
Next year.
at all. So.
Yeah, next year. And so hopefully you'll put something in the Orion newsletter.
Yeah.
That would be good. So I'm just delighted he's here. I think all of you will enjoy his presentation. So thank you so much, Ted. Ted Stryk.
Great.
From Rowan State, of all places. So welcome.
Thank you.
Thank you.
Well, it was a better start from the last time that I was sitting in a row of theater chairs and to come speak at a place, and I tripped on my way out and face planted in front of everybody and was really trying to recover, but it really hurt. Before I get started, something David said just kind of made me think. I never really thought about it as getting the telescope closer, but that's largely is kind of what the spacecraft does when it takes images. I'm going to start with an image that I had nothing to do with, and this is, you've probably seen it, the garish vintage 1980-81 Voyager Saturn images. One of them. This was a classic example of an image that was processed to go in a scientific paper to show color variations, but the press people thought, hey, it looks cool, put it out there, and it got sent out. Well, I was a fourth grader sitting in science class, and I was bored, and so I was paging through the textbook, and I came to the image of Saturn. And my reaction when I saw this was nothing natural could possibly be that ugly. There's just no way. And I looked through other books, and sometimes it looked more like this, and sometimes it looked more like this. That was actually one I did process. But I had one of those sad little refractors that somebody had given me for Christmas, and so I spent 2 hours at way higher power than the little telescope like that ever should use, searching for Saturn before I found it and verified that it in fact was yellow and not those garish colors. That started a lifelong interest in astronomy. I joined the Bristol Astronomy Club soon after that. It also fostered an interest in imaging and the whole process, behind imaging and what goes into planetary images. I would go on, I can't remember if David mentioned this or not, as a teenager to work as an intern at the Bays Mountain Planetarium, and we had a set of, there was, crude internet with NSCA Mosaic available there, but also we had the full set of Voyager, PDS, Planetary Data System, CD-ROMs, and so I was able to begin to kind of look through some of these data sets, and I became very intrigued. And, of course, eventually I went off to college, although I did, while I was at Carson Newman, travel back and continue to do some work at the planetarium. But it so happened that as I was living in a little dorm room, I generally didn't have my telescope with me anymore. There wasn't room for it there, and so I didn't have it most of the time anymore. And I began to become more and more interested in different planetary image sets. Now, there would also be a combined thread, which is that while my mother, when I was a child, was working on her master's degree at ETSU, she would often put me in the library. So I would dig, while I was looking for something to do, through a lot of the old government documents and books, and I would read all the real-time accounts of Voyager and the Mariner missions and the Viking missions and a lot of the Soviet missions as well. And so I gained a really good idea of the history of exploration. And so I would work with these data sets over the years, and the way I was introduced, I felt like I needed to tell that story now, and so this will get me a little out of order here. But to segue to where my planned talk really begins, I would end up really working along two lines. One is restoring older images, such as some of the old Soviet images, but also working with NASA images to clean them up and to try to get the most that I could out of them. And that's when originally John Spencer and then Alan Stern on the New Horizons team contacted me and asked me to get involved. So that's how that happened. And worked a lot with a guy named Todd Gore on a lot of this, but this is some early work that we did using, actually, this is more using his algorithm than mine, but combining some of the early Pluto images to get a much clearer view, both by stacking and deconvolving. Now, I've done a lot of stacking with Voyager images, which is honestly a lot more like the stacking that some of you all probably do with Earth-based images. In your case, compensating for the atmosphere. In Voyager's case, compensating for the fact that a lot of the images are smeared or jittery, and stacking them to get the best result, the best frames, also to improve the signal-to-noise ratio. But with New Horizons, it was simply to improve signal-to-noise, and also you had a CCD that was undersampling the full resolution of the optics, and so you were able to improve the resolution slightly by matching these up. And with some of the closer images, I'll give an example here of an original image versus some of the stacked and deconvolved images that we worked on. As you can see, hopefully from the distance you are at, the detail is much sharper. And so I guess that's the history. That's kind of the end of that history. I wanted to go through some data sets that I've worked with applying these techniques. One of the most interesting has been some of you may remember, and I mislabeled this slide. It's from 1999, and I wrote 2001. but the Deep Space One spacecraft, it was a test spacecraft launched by NASA in the mid-90s, and it was supposed to fly by an asteroid and then a comet. Comet flew by Comet Borrelly and returned some excellent imagery. And unfortunately, when it flew by the asteroid Braille, when they named it Braille, you knew that there was going to... They cursed themselves. And sure enough, the camera had... the official story is that the camera mostly missed. The in situ instruments took their data, but the cameras missed, studying Braille. And it was a little worse than that, in that they were testing some automatic imaging software to edit images to avoid sending back unnecessary parts of the images. And the asteroid was actually in the approach imagery, and they edited and the software edited it out before transmitting it. And basically, the Micus camera on DS1 had such a bad light leak that the software focused in on the light leak instead of the designs, instead of the asteroid. But when it turned around to image the receding view, it did get a few images. And you'll often see this one on your left. It's a very pixelated view, but there were several images taken. And in stacking and deconvolving, you can see it's either 2 or 3 part binary. It's a very it's a very high phase view, so you're looking at a crescent view of it. And also there's a second, slightly more distant version. And so taking a few minutes later, so you can see it shifting relative to the spacecraft a little, but you can still see that 3-lobe structure with the last lobe coming a little bit more into view as the angle changed. And so I was able to get something interpretable out of uninterpretable images. Another example where this has worked is from the Spirit rover, the heat shield. Stacking lots of images to bring out the heat shield. And this was a real challenge. This was one of the ones that I've gotten a lot of interest. This is a Voyager image of Miranda, moon of Uranus, with the surprisingly active geology. But when Voyager flew by the Uranian system, Uranus is, of course, as I assume you probably know, tilted on its side. And Voyager, unlike its other encounters, where it encountered moons and the planet one by one, it went through like a dart heading to a dartboard, except that, of course, it didn't hit anything, so it went back off the other side. But it encountered everything at once. And you had a tape recorder that could hold a whopping 36 images. And so it took very few images of each moon and the planet during closest approach, as well as a set just before closest approach that it then transmitted. And there was very little color data because Voyager, as most spacecraft, there's some exceptions like the Curiosity rover, it took individual color filter images that were combined for color. And this was the best color view of Miranda, and as you can see, some of these images are very limited. The clear filter is well exposed, but missing a good part of it. And the other images are somewhat blurred, they're badly underexposed. And I worked on calibrating them and also using some even more distant data, reconstructing the missing color areas, and creating a complete color view of Miranda, which is the highest resolution we have. that's in color. Probably the most well-known thing that I have from the Uranian moons, however, would be with Ariel. I was working on a mosaic of the highest resolution images of Ariel, which are badly smeared towards the top, and I was working on an algorithm to desmear them, which worked very well. I also was working to calibrate them very well, and I was frustrated because I kept seeing these little fuzzy things off the side, and no matter what I did, it wouldn't go away. And I was confused because I'd done a lot of experimentation with images of the Saturnian satellites, because with Cassini in orbit around Saturn, there was some ground truth. In other words, in trying to get the very most out of the Voyager images, I could test techniques using, say, Enceladus, and then look at Cassini images to see if what I was pulling out of them was real, or whether it was an artifact. And in calibrating those images, this never happened, and I couldn't figure out what it was. And in desperation, I just really stretched the contrast, and I noticed, now this is a cleaned up version, but I noticed that the limbs seemed to continue. And so just out of curiosity, I ran a simulation in Celestia, which is a program that does solar system simulations, just to see where's Uranus relative to all this. And sure enough, this side is in reflected light. Normally people use it, we call it Earth shine or Jupiter shine or Saturn shine. I usually just say planet shine for Uranus to avoid, Uranus shine. But you could see the probably a ray crater, some other mottled features. Most interesting thing, I'm getting too far from the microphone. The most interesting thing is this tectonic feature, Cecina Cosmata, which clearly you can see the line, and there's a few other more distant image sets that show the same thing, continues into the northern hemisphere, which was completely in darkness other than planet shine. So this indicates that it's a global tectonic feature, sort of like we've seen on the Saturnian moons, which is something that we couldn't have gotten from the limited coverage that we otherwise would have had. And, right now we know very little about the northern hemisphere of any of the Uranian moons. It's unfortunate. There was a plan for a New Horizons 2 that would have flown by Uranus in around 2012 during the equinox and completed our maps. And NASA was going to do it, but the budget overruns on the Curiosity rover ate it. And so if you ever hear from Alan Stern, the principal investigator for New Horizons, don't bring up Curiosity. He's still very hostile towards it. A lot of the controversy has to do with the fact that the budget projections for that mission just never really added up from the beginning. Fascinating mission, but it was one of the budget projections were basically, if everything we're developing goes exactly right the first time, and no piece of equipment ends up costing more, and we don't have any delays at all. Of course, you know how often that happens. So, I'll look for other examples of planet shine. This is Neptune's moon Triton. Able to map out, you can see that there is planet shine, processed from desmeared images like the one over on the left. Unfortunately, the images are either so underexposed that it's hard to pick up the night side, or they're smeared. And so that is something that I am working on right now is trying to either from some of the shorter exposures build up a decent image or work on desmearing these more. What Triton is another world where we didn't see much of the northern hemisphere. And a big question is, does it, in the Voyager imaging, and I'm going to show a lot more of that actually, in the Voyager imagery of Triton, we have not been able to. There's clearly a south polar cap, but does it have a north polar cap? And we don't know. There is another one of these looks like another example of it being desmeared. I don't think those features are real. I think they're noise. This is a stack of 4 images. Like I said, some of the shorter exposures, as you can see, it doesn't pick that up at all. And now it won't advance. And I've taken this too to Charon, moon of Pluto, and studied it in Pluto Shine. And we recently published a paper with regards to this, but we pretty much that area, Mordor, as we call it, towards the North Pole, which was illuminated, is dark, and we think that gunk is from Pluto's atmosphere that's coalesced there. And we were wondering, if that's true, it should really be at both poles. And the way this is showing up, you can't really see, but we have detected that there is an indication of a darkening in this barely illuminated imagery that shows that the South Pole, which is in seasonal darkness, also has something dark on it, which indicates that our explanation is correct. And just another, this is a more distant Pluto image I've worked on, mainly to bring out, if you look up at the upper right, the Seminole crater. We were trying to figure out the relief of it and finally got an image right on the terminator to get a good view of it. And this is that image at the same scale, just to give you an idea, relative to a Rosetta image I processed of Mars. Same size, same pixel scale. And just to give you an idea of how those worlds look relative to one another. Moving into Triton, this is Voyager sequence of Voyager passing by. This data, when I started working, it was over 20 years old. For the most part, only approach imagery used, at minimum 20 years before we could get back. This data's old, but it's probably not halfway through the time period in which it's going to be our best view. And it's the most Kuiper Belt-like thing that we'd ever seen, and at least we saw it. And that's how I ended up getting involved with New Horizons. They saw my work on it, and they invited me to come speak. So I've taken this is a public release version, this is my version of approach image. Most of these color flares you see are not real, they're misaligned imagery. And some of the images cut off the bottom, not all of them did, and I reconstructed the missing parts from the ones we had. I worked on, and you can probably see the similarities to some of that distant Pluto imagery, some of the distant Triton pictures. And one of the things that came out, which gave us hope of finding plutonium plumes, that didn't happen because it doesn't appear there were any, at least in the area we looked at. But down here at the very bottom, we were able to pull out some of the plumes that were only seen after close approach in some very distant imagery. We were able to see the shadows near the terminator. And here are Pluto and Triton together now. And as you can see, there's some vague similarities, but they turned out to be a lot more different than we expected. First of all, and we kind of had a clue about this soon after the Voyager encounter, Pluto has more extreme albedo differences. You might notice how strong the contrasts are. But also, Triton is relatively smooth. Doesn't show nearly as much topography. That probably is due to the fact that it was melted down when it was captured by Neptune. And so, while it certainly does have topography, very smooth terminator as Voyager passed by. And it took the really close-up imagery. This is some of the best Voyager imagery that I'm going through. Some of this is seen often. Some of these images are not seen as much because a lot of these were badly smeared. But the resolution here is about 350 meters per pixel. So, if Neyland Stadium were there, you could see it. You wouldn't really be able to tell what it was, but you could see it, which is by far better than anything else we have for Triton.
I have a question.
Yeah.
What does smeared mean?
Smeared, basically, as the camera moved, as the spacecraft moved by whatever it was imaging, the image smeared. It
So
didn't hold steady.
The greater smear, but the shorter the
Exactly.
exposure, the less light comes in.
Exactly, and
The trade-off.
we wouldn't have seen anything with a very short exposure. There are two things that made it better for New Horizons and Voyager. First of all, you're dealing with early 2000s technology versus early 70s technology. You're dealing with exposures of a few seconds versus sometimes for Voyager 45 seconds. But the other thing is, this hurt us and helped us. But New Horizons, it took it a year and a half to send all the data back. It transmits very slowly, and it also could not transmit data while it was actually making observations because the cameras are rigidly mounted on the spacecraft. Whereas Voyager had a scan platform, so it could be sending back data. When you can only record about 30 images worth of data on your tape recorder, you have to be able to do that. And the scan platform would turn around while it was taking pictures and compensate for its motion. But spacecraft that are built like that with a scan platform, the downside is when you have something moving, it shakes and it resonates. Whereas if you have a rigidly mounted spacecraft where everything is basically bolted on, and you have modern thruster technology, it's rock solid. And so the only images from New Horizons that are smeared are some of the ones that were taken while they were called rider observations. Basically, while the spacecraft was turning to use another instrument, it took a picture because of a unique angle. Yes, it would be smeared, but you only have so much time during the flyby. You've got plenty of data storage, you might as well take a picture. But New Horizons didn't have any smeared images that were not expected to be smeared. But I'm using that in a totally normal version of the word, not some nothing. There's not some real trick to it. It's the same thing as if I was at a handheld camera and was trying to take a picture of you all, and my hands were shaky. It would come out with a smeared image. But there were these frozen lakes and such of nitrogen ice that were seen. The famous cantaloupe terrain, because they didn't really know what to call it, except it kind of looked like the surface of a cantaloupe. And the image used on the left is pretty well known, but there's a second image, one on the right, that extends the coverage. And then as it passed through closest approach, the wide-angle camera continued to image. But then after closest approach, there's another sequence. And it's not as well exposed. And it doesn't use nearly as complicated techniques, honestly, because Voyager had a limited computer memory and they could only store so many commands. But it covered an area that wasn't seen. So we got these thin crescent views. And then some of these views that shows these tantalizing features that kind of resemble the features on the side we saw, but are hard to interpret. And also we saw, if you look up those little shadowy clouds which turned out to be match up with some volcanic plumes. They were the ones I showed you in that distant image. They appear there again. And I was able to get more out of these images than we had, and that was another reason I got involved with New Horizons. It's kind of a grand mosaic of the distant data. One of the things that's very interesting, and this is true for Pluto too, is you might notice the whole kind of composition looks very different from the approach imagery. The coloration and albedo patterns are very phase angle dependent, which means that it looks very different under a low sun angle than it does under a high sun angle. This is a process just to bring out detail a little more. Close up, you can see what looks like a crater and some tectonic features. And this is how the night side, that gray area, matches up with the day side coverage. So as you can see, it extends it considerably. There it is again, relative, put on top of a map, and gave us a more complete view. And again, this is the only way we can extend our coverage of Triton, because other than some Hubble Space Telescope images that barely resolve detail, this is all we have. And I worked on a map with Phil Stryk of Western Ontario, who used my images to do a map of terrain types, and this is what we came up with. Because this is the best, that's Triton right there in the original image, that's enlarged, but that's the best Hubble can do. So far I've been summarizing my work with Voyager and New Horizons, but I mentioned I also work with older data sets. This is Mariner 4 Mars imagery put together. Some of the very first images taken outside the Earth's moon system ever, mosaic together. This I did using scans from some of the original publication. Believe it or not, in many of these older missions, the digital data is lost. They made really good prints and then chucked it. There is lots of documentation that talks about a printed out set of matrices for Mariner 4 of the original digital data, but not even JPL can find it. They supposedly have the master copy, and it doesn't appear to exist. So other than some fragments, it's lost. There was a Mariner 1969 flyby. This is an approach image. This is a scan from a book. This is what they typically look like. The digital data does exist, and using both the color overlay and cleaning it up, I was able to get this out of it, which is a much more realistic portrayal. I was able to put together some of the mosaics of imagery using modern processing. It's a very difficult data set. Here's a color view of Meridiana, the area that the Opportunity rover is exploring. Opportunity would be right in the upper corner of the dark area on the left-hand side. But this is, of course, from 1969. And this is a very difficult set. What they did was they transmitted every seventh row back in digital data, and the rest was analog, and they combined them. They could have taken about, the Mariner 6 and 7 could have taken about 4 images each if it had been all digital. They couldn't store it. And so they got this idea of combining digital and analog data to send back more. And I've actually seen the original publication where they published a report on the imagery, and somebody hand wrote on the top of the description of the techniques, "Never do this again," because it worked so badly. And Mariner 9, the first Mars orbiter, would not use that technique. It would go fully digital. But finally, for Mariner, there's a South Polar cap. And you may have seen a lot of these in books where the images don't line up and they're, 1960s processing. Another image set that I have worked with and have pursued is Pioneer 10 and 11. It's rather unbelievable, but the digital data is largely missing. And so I went out to Ames Research Center and scanned some of the best scans. I found some fragments that I've used of the digital data that I've used for ground truth. Tom Garrels, who was in charge of the imaging photopolarimeter, which was the imaging instrument, hated computers. He was one of these people who just longed for the day we could send a film camera out there and bring it back. He hated computers. He didn't like computerized instruments. And so he wanted everything printed out and then had the tapes recycled. Supposedly somewhere, the digital data was printed out in matrices, and paper matrices of ones and zeros, and nobody knows what happened to it. And my fear is that it's in somebody's office, and that person is going to pass away, and a relative is going to find it. What's this? Trash. You know. It keeps me up at night, honestly. That image of Ganymede was actually from a digital fragment that we still have. This was from closest approach from Pioneer 10, which until Juno was one of the closest images ever taken of Jupiter. And you might notice the funny shape. It was so affected by radiation that it shifted several times during the picture, and I was able to to fit it back together. Unfortunately, the next image would have probably been the image that discovered volcanoes on Io, and due to the radiation of Jupiter, it missed the command to take the image and never took a picture. It did get a neat view of Jupiter and the little crescent Io, one of its moons under it, as it disappeared. And then its twin, Pioneer 11, got a really nice view of the red spot. You might notice if you've looked at the red spot recently that it's not nearly that big anymore. It's about twice as long as it is now at the time. And one of the reasons why I really would love to find the digital data is in studying the features on Jupiter and on Saturn over the years. It's worthwhile to have some higher resolution data from the past to compare to modern data, and it's hard to be quantitative when all you have is printouts of images compared to actually having the quantifiable digital information. Here's a slightly closer view, but without the red spot. And I just wanted to do a comparison. This is Pioneer 11 still, but that is Pioneer 11 looking down at the pole of Jupiter, and on the other side is Juno, which is in orbit now. And so it's interesting to compare how the same regions of Jupiter have changed over time. And hopefully we'll be getting lots more from Juno. It's not, I don't know if you all are following that mission, but it was supposed to move into an orbit where it would be encountering the planet frequently, but its engines didn't fire. And right now they're just letting it stay in its insertion orbit where it only approaches close every few months, because there's a fear, given what has happened with other spacecraft with the same engine that have had that problem, that it could blow up. And basically the plan right now is to get a decent amount of data slowly, and then afterwards give it a shot and see if it can be put into the right orbit. And if not, just don't do it. And lastly, this is the reprocessed Pioneer 11 image of Saturn. Took until 1979 to get to Saturn. The rings are so dark because they're on the unilluminated side. The sun is coming down on the other side, relative to, and you really accept sometimes during a ring plane crossing, very rare you can ever see the dark side of the rings from Earth. And just for some interesting perspective, and I combined it. This is on the top is Pioneer 11, 1979. They're all from about the same angle. Next is Voyager 1 in 1980, and as you can see, the rings are now illuminated, and then by the time Voyager 1 got there, The ring, but in 1980 it was still almost edge on. In 1981, the illumination angle on the rings is higher, and as you can see, they look brighter. Basically, it's a difference of almost edge on, lots of shadows if you can see closely, versus a much higher illumination angle. So seeing the seasonal shift on Saturn, it's almost like having an orbiter that approaches once every 3 years. And what's exciting is that during the most recent ring plane crossing, Cassini observed almost the exact same seasonal sequence at Saturn, and so that gives us a nice little baseline for comparison. These are, I don't understand why they're going off frame, but these are some reprocessed Mariner 10 color images of Mercury. I don't know why they're but that's a nightmare set to calibrate. And another big interest of mine, Soviet imagery. It's amazing, first of all, when it comes to Soviet images, how much of what we see looks like it came off of a bad photocopier, because it did. And, just the horribly degraded forms. And a lot of it is because they did a press release, they photocopied it, or sent it over a fax machine, and that got published in a U.S. publication. So we have a 1970s era fax that is, reprinted all over the place. And there's also a lot of legends. One of the things that first got me questioning some of these data sets is, if you look at any account of Mars exploration from the 70s, they tell this story. Mariner 9 arrived at Mars, followed by the Soviet Mars 2 and Mars 3. The landers crashed. One of them transmitted for 20 seconds, actually, Mars 3, but returned no real data. And Mars 2 and Mars 3 orbited. However, there was a global dust storm going on, and because Mars 2 and Mars 3 were Soviet and had bad programming, they couldn't alter their image sequence. And so they just took blank images of the dust storm. Well, I learned two facts that were troublesome. First of all, Mars 2 had a transmitter problem and didn't send back images at all. It sent back some other data, but images were too big for it to send back. Mars 3 was put in the wrong orbit. It had a fuel leak and didn't have enough fuel to get in its proper orbit, within a much longer orbit. And it occurred to me that if it really followed this pre-programmed sequence, virtually every picture it took would have missed, because it would have been in completely the wrong place. And so that wasn't true. That's a legend that I have no idea what came from. The only thing I can get is the earliest account is in a book by Patrick Moore, and I think a lot of people figured if the famous British popularizer Patrick Moore said it, it must be true, and they just repeated it. And now it does turn out that Mars, the reason there wasn't more of an attempt to release Mars 3 imaging, and I think this is why they were happy to say, yeah, the pictures were all just blank, was that its imaging system was not up to that of Mariner 9. The American spacecraft was there. But it got some interesting perspective still. These are two crescent images of Mars from Mars 3 that I processed from very horrendous original sources. And these are done they're from a film scanning camera. The one on the left is taken in December 1971, when Mars was completely enshrouded in a dust storm. The one on the right is from February 28, 1972, when the dust had largely settled. You can see the polar region toward the top and some albedo features. And so it gives a much more global perspective than we have of the dust storm settling. They're neat images. And this is where, remember I told you that I used to, as a kid, I got left in the library a lot, and I would search through publications. And this helped me know exactly where to find where a lot of this imagery might be. This from 1970 is the Soviet sampling spacecraft, Luna 20, working on the moon. That's its sampling arm, moving around, collecting samples and looking for a place to drill to return to Earth. And the horizon is off to the left. It's kind of an awkward angle, but the sampling arm worked for a few days and then it returned. Another data set from the Soviet Union that was very dear to my heart. I became interested in this. Of course, I showed you the Saturn image, but I became interested in this in 1989. It was 1989 when I was doing this, and the two big things going on were Voyager Neptune and Phobos 2 at Mars, which was a short-lived Soviet mission that failed before its closest approach to Phobos and before landing, but sent back some imagery. Probably a good time during the 1980s because there was an unusual amount going on, really until the mid-90s at the time. But I got it. One of the first things I got interested in was processing something. This is Phobos over Mars from Phobos 2. It's a very difficult data set to work with. It only returned 2 color filters, so you had to red and blue, so you had to create green as an average of the red and blue. But the images were typically like this. Lots of readout issues, lots of instrument noise. You may see, if you go to conspiracy websites, this image is rather famous. That little white spot, that little white line, they claim is a missile that was heading for Phobos 2, and they say that's why it stopped transmitting. There's lots of problems. First of all, this image was taken almost a month before it stopped transmitting. And second, that issue is in lots and lots of images, that white streak. It's a problem with the blue channel, the blue channel of the instrument. But, they were going to fly me out to Los Angeles to be part of a documentary on Phobos 2. And they ended up cutting me out of it because they asked me, first, so do you think there's any possibility that it was actually hit by an alien missile? No. But if it was an alien missile, how was it launched? That's not really a relevant question because it absolutely wasn't. And after a while, they got tired of me because I learned from bitter experience. I once was interviewed when a Russian scientist had published in Leonid Transformality in several years ago, published a paper claiming that the Venera images of the surface of Venus showed life. And it was a more delicate situation than most situations like that, because he was one of the leading Soviet scientists, and quite frankly had become senile. And so it was one of those things where, unlike some of the conspiracy nuts, people were trying to be kind of gentle and not cruel to him, because, again, he had a long, distinguished career and, was just, frankly, slipping, and nobody wanted to humiliate him. But anyhow, I had, because I've worked with, and I'm going to show some of my work with the Venera images, I got contacted by a radio station and several news sites for interviews. And one of them, they sent me a questionnaire, and I explained the instrument noise that was behind what they were seeing. And there was also the fact that you could see the lens cap on both sides and of the spacecraft. And the person asked me, how did it move from one side to the other? And I explained that there were 2 cameras, and so you could see, that's why you saw the lens cap on both sides. Well, when I saw the interview come out. They asked me about what these life forms were, and I said that it had to do with the lens cap of the cameras, and you could see them on both sides. And they took my description basically of the lens cap and put it with the question about life forms, and it sounded like I was saying there was life on both sides of the cameras. So when I was dealing with the people on Phobos 2, the Phobos 2 thing, I was extremely careful to not give them anything that could be misconstrued as, that could be taken as a snippet out of context. One thing I found is when a so-called journalist really wants to get a story out of you, they will get the story they want no matter what, if you're not careful. But I was able to clean these up. You might notice a difference in shape. Another difficult thing is the pixels are rectangular, so they had to be properly stretched to compensate for that. But these are two versions of the image, one based on the red channel and one based on the blue channel, in terms of the positioning of each world. And I had to process Phobos and Mars separately, which is pretty typical for images of more than one object because of the time between images. This is another image from Phobos 2 of the Valles Marineris system. This is a Venera 14 image of Venus, and this is one of the images that was in question in that interview. But it's an attempt to get a more human perspective. These scan across. There's lots of issues with the imagery, but given there are no plans to revisit Venus, these are the best views that we have. This is a combination of, this is from each Venus lander that has taken images. Venera 9 on the top, Venera over on the right-hand side, that's Venera 14, Venera 10 on the top, Venera 14 on the right. At the bottom, still going clockwise, is Venera 9, and on the left is Venera 13. They tried some new lens caps on Venera 11 and 12, and they melted to the cameras, so no images there. And I wanted to make a combination just to show how different each of the landing sites are, and just teases us. We really need to go back to Venus. Just how different, just with these very limited data sets, how different these areas can look. But this is another set where a lot of what we have looks like it's from a bad photocopier. But these were also, and the order I put them in was just, I thought it looked good like that. And so right now, I've continued to work with New Horizons. It was just before I came here in a planning meeting. We're headed for a 2014 MU 69, which is a small Kuiper belt object. And so hopefully we'll be doing lots of processing work with that. I will finish with just a pretty picture of Saturn from Hubble in 2011 that I worked with. I just really like it since I started with Saturn. And I guess any questions? Yes?
What was that artifact? Go back one image.
Oh, what did I just do? Well,
on the left side there, is that something that's on the Venera for a measuring?
yes. Interesting story there. That was basically a color swatch to calibrate the color. Unfortunately, nobody sought to test it under Venusian conditions, and the chemistry in the paint reacted and changed color on the surface. And so and because we don't know the chemistry of Venus's atmosphere to do it exactly, we don't know. We know from what we were able to do that the color definitely changed, but we don't know precisely. Another problem with this set is that the blue filters are almost blank. Little bit of signal, but very little because they underestimated the exposure needed. But yeah, that is there. You might notice a little artifact at the bottom here, which is gamma ray spectrometer at the very bottom of that, sitting on a rock. But yeah, those color bars that should be red, green, blue, and the green pretty much turned white, and the blue, particularly on Venera 14, reacted as well. And to be clear, these landed within days of each other, so there wasn't much that could be done. And let's see, I see a hand.
Have you noticed any change in NASA's attitude toward archiving data since you've been going back getting the data you can find and processing it, showing new things?
Yes, actually. I don't know that the attitude is... There's two things that have changed the attitude. First of all, there is the fact that you can access most data sets. So some of these really, of course, this doesn't go for Soviet data, and it doesn't go for some of the really old data sets that aren't digitized or in some arcane format, but for most of the major data sets, they're available online now. So it's not a hassle, first of all. And that's helpful. And it used to be that you had to go find a Planetary data system site and go there to a regional Planetary image facility and try to figure out who had what, which from what I understand was a nightmare. And the fact that people like me and others have found some interesting things in them, a lot of scientists are very open to that. For one thing, that I have a recent Lunar and Planetary Science Conference abstract, which has gotten a lot of interest, where using Voyager data, I've pulled out some of the plumes on Enceladus that Cassini detected. As somebody who is not having to follow grant money to keep my career alive, I have the luxury of being able to dig through data and risk, as long as I get some pretty pictures of it, risk not finding anything. And it allows me to sometimes find some really interesting stuff because I'm able to just sort through it and see what's there. Didn't want to show my entire portfolio because I didn't want to be here for hours, but was able to find one of Neptune's moons transiting in some of the Voyager imaging. The other thing I've noticed is that science teams, especially older science teams, because you had to print out pictures, you process them on a VAX where you couldn't, old VAX computer where you couldn't even look at them as you were processing them until they printed out. It was much more time consuming. You couldn't just sort through stuff. So you had images that were designated for the atmospheres people, for the rings people, for the moons people, and they didn't typically look at each other's data. And these images happen to be labeled atmospheres. That's true with both Enceladus and with the Neptune imagery I'm talking about. And so I don't think anybody who would have been interested in it probably ever looked at it at the time. And so that is something that people like me can often go back and find. Another thing that probably revolutionized amateur involvement in this kind of work, and you could really thank Jim Bell, who is over the camera on the Mars exploration rovers, but he decided, without anybody prompting him, to immediately release all the images in JPEG format online. What he figured out was that, we'd had landers on Mars before. We had landers on Mars, and using an uncalibrated JPEG image, unless some alien walked up and waved hello, nobody was going to make a scientific discovery that was going to supplant the team using that. But what it did do is get a whole bunch of people engaged with the mission, who then, of course, when the data was officially released, would go back and learn to process it. Had several people, Doug Ellison, Mike Molaska, who worked with this kind of data from spacecraft and who are now working professionally on it, and people who had backgrounds of studying image data were able to work their way into the field that way. The Cassini spacecraft followed suit. Now, that was against their will, and the Cassini people are the only people I've ever gotten a hostile reaction from, although they've come around, although the imaging team leader still hasn't, but that's another story. That is a very interesting issue. She has a production company and doesn't like the idea that she views other people who work with as a competition, never mind that it's taxpayer funded. But still, they had to release these to where people could use them, and so it allowed people to work with the data. We did a compromise version. It's a bit embarrassing with New Horizons, with the imagery. We originally said we were going to release it every day as it came down. We changed our mind and did it every week at the last minute, and that was because of NASA. Specifically, the fact that we would create our press releases, and their process of vetting those press releases took so long that we realized that we were going to get scooped every time. Every time, there would be lots of images out days before our images came out, and the official ones, and nobody would care. So we had to slow down the pipeline a little because of NASA's vetting process, which was very insightful to see how that worked. But Pluto was different than a Mars rover, too, in that during closest approach, and when the first close-up data was coming on, you really could make a discovery just looking at a JPEG. Just discovering that there's a large smooth area in the center, or the heart-shaped feature, or some of the big tectonic features that it observed. I mean, everything was new. But still, we wanted to keep people engaged, so once a week was our compromise. So, point being, there's been a real effort, I think, to bring people on board. I mean, like I said, I was actually brought onto the New Horizons team. The Planetary community is very small, and so having extra sets of hands that know what they're doing is very welcome. And I, along with most people, I try to be very careful. If, for example, I'm working with Hubble data, if the person who's the experimenter hasn't published yet, and they've recently got the data down and it's been released, if I have done something with it, I'll often email them and say, would you mind? Do you mind if I do this? And if they say yes, I'll wait until they publish, because I don't want to be seen as somebody who's going to, be the person who didn't go through the process of planning the observations and then ran in and claimed their data. But overall, the amount of collaboration between amateurs and professionals has been really good. Of course, with Juno, there's been another layer, which is that a lot of amateur astronomers using telescopes, their imagery is being used in conjunction with the instruments and imagery from Juno to put it in context. It flies by once every few months, whereas amateurs can monitor Jupiter constantly and put that data in context. And the quality has gotten to where it really is almost indistinguishable from most professional ground-based data now. And so that's been a real development. Any other questions? I think I see a hand, but yeah, okay. Sorry, it's with this light in my eyes. I can tell that there's people, kind of.
You were saying something about having to paint artifacts out and so on. I was just wondering, do you ever get accused of being the one who's, keeping the UFO as a secret, and how do you deal with it?
Sometimes it depends on how I deal with it. With some of the more extreme people, who accuse me of being part of some plot, there's probably not a point in discussing that. But for the people who ask me what I'm doing, I usually try to send them some example of how, like, a certain feature shows up in every image, no matter where it's pointed. I show them what the original images looked like. I try to send them an explanation of the camera. That can be effective at times. When when you have somebody who's really curious, what are you doing with this imagery? And I think I found that it was actually when I first started giving a little bit of attention for my work in the late 1990s, it was actually harder to explain because most people had never worked with a digital camera and digital imagery at all. And now they have. And I find that because of that, the idea of noise on a chip or hot pixels and different things like that is not lost on them in the way that it once was. So that's been a big improvement. But some people, they come asking you convinced of the answer, and, contradicting them just makes me part of the conspiracy. Before I'll get your question one thing. And the one thing I just never have understood is, given NASA's struggles with funding for planetary science, if they were detecting evidence of alien life, why on earth would they hide it? I've never understood that. Yes?
Have you noticed that most of our pictures of the other planets in the solar system have one similarity in common? They all look like piles of rubble.
Well, that or big swirling balls of gas.
Yeah.
Yeah, I mean...
Or ice.
Or ice, yeah. And if the Psyche mission to the asteroid Psyche exists, we're going to see in about a decade, we're going to see our first metal world. And so, but I mean, we are dealing with, ultimately, worlds that have a lot of rubble on them. That's very true. And, with less to cover it over. If you look at some of the recent Curiosity imagery, it looks a lot like the Southwest. A lot of the earlier Mars missions, even where Spirit and Opportunity started off, it's kind of circular. A lot of lunar missions too, they landed on flat plains because it was easy to land. And so that's why a lot of the sites looked rather similar, is because we were picking the same self-selecting kind of places that were easy to land. I mean, if you're thinking, if you were looking for a place to land on Earth, and you had maybe a 50 mile wide, 250 mile long ellipse that you were going to land within, and couldn't really maneuver as you were going down, you'd probably pick some place in Kansas or something to land that was really, really flat, where there wouldn't be the side of a mountain you could slam into or something. And, of course, without vegetation and such, you have then exposed rocks and dirt and rubble piles, and that's why a lot of the imagery tends to look similar. I think that's one of the exciting things with the precision landing system on Curiosity, and also the fact that Spirit and Opportunity were able to travel to some more complex areas, is we're finally actually exploring areas where if we looked at a globe of Mars and said, I want to go here, we might actually go, rather than what's easy to land, or where is it easy to land. Any other questions? Okay.
Ted, thank you.
Oh wait, I have one more question here.
Okay.
I think.
That image on the 9 o'clock
Uh-huh.
looks a lot like a landing strip.
It does, doesn't it?
And there's even
Yeah.
a red mark for the touchdown.
Yeah. You're on to the conspiracy now. Uh-oh.
Right, so now you can go on YouTube and have all kinds of crazies.
Oh gosh. Oh no.
NASA did not okay you using that one, right?
Well, it's a Soviet one, so
Okay.
yeah, so it's been leaked out.
What's the Russian reaction to this? They must be very interested in what you're doing.
In the past, it's been very positive. In fact, they've been very helpful in providing raw data to use. They've wanted their imagery out there. Sadly, in the past 3 or 4 years, a lot of them have clammed up just because of the fear that if they're sending anything technically related to an American, they might get in trouble. And with the tensions between our countries, and so unfortunately, it seems like of my contacts there, some of them have dried up, and the rest have emigrated and are here.
Thank you.
Thank you.
Okay, this is a little addendum, this is, an Orion Cup,
Oh, thank you.
and.
And there's Orion.
Yes, and this is called a mugging, so.
Well, I can say I went to give a talk tonight and I
Got a
got
picture,
mugged.
Roy?
I got one,